This video is for my HS physics class based on question 2 from Working with Distance Time Graphs homework. Okay, so we've got this picture with a toy car and it's going to move around a circular track. The radius there, don't forget, there's some important information in the first line. And now the question asks, how far does it move along the track when it goes from A around to B? Okay, so that's halfway around the track. If I do halfway around the track, and it's a circular track, so basically I need half of the circumference. So the distance is going to be 2 pi r, which is the circumference divided by 2. And that means there we are with 3.14 meters. Now for the time taken, we've got the equation for us when we're traveling at a constant speed. V equals S over T. Now let me just remind you what each of those pieces mean. So V is for speed, S is for distance, and T is for time. Now you might say, well, why don't you use D for distance? And well, this is what I'm used to. This is what I use in the IB as well. For those of you who have English as a first language, you always assume that the letter matches the word in English. But you know, a lot of the times we're not the ones that have come up with these things. And anyone working in a second language probably doesn't have that same assumption. Okay, so we are going to use V equals S over T. Now, if I move that around, I need to get time. So I'm going to take my equation, S over T. If I multiply time, because I don't want time in the denominator, I want it in the numerator. So I'm going to multiply both sides. Cancels out the T there. But now on the left, I have T times V. I got to get rid of the V, divide both sides by V, and now I have T equals S over V. And if I put my details in from A to B, it says we've just found it's 3.14 meters. And then it's also going at a speed of 0.6 meters per second. And putting that in my calculator, I get 5.2 seconds. Okay, now C talks about displacement. And if you remember that displacement means the distance as the crow flies. The idea being is the crow's not going to walk along the streets and it doesn't care if there's twists and turns. A crow's going to go from here to here in a straight line. That will be our displacement. Well, that will give us the magnitude of our displacement because if you remember, displacement's a vector, so I also need a direction. So it's going to go from here to the other side, because it's halfway around. That total distance, or the total magnitude there, will be 1 meter for the radius, and the other one, 1 meter, a total of 2 meters. And for my direction, I'm going to say to the right. So recall, we put our directions in square brackets. So now let's move on to average velocity. The equation is very similar to speed, but remember, velocity is the vector equivalent of speed. So that means we're going to have velocity being displacement over time, not speed as distance over time. Now we still use the same letter, so you just have to be aware that we're talking about the vectors right now. So in this case, our displacement was 2 meters, and it's taking the same amount of time. So the time we had found back in part B was 5.2. So 2 meters, 5.2 seconds. That's going to give us 0.38 meters per second. But remember, that's just the magnitude. That's just the value. We still need, for velocity, a direction. And in this case, it's going to be the same direction as our displacement. It's to the right. Now, one last thing I just want to point out, it's not a question here, but I just want you to think about it. We talked in class about if we started at A and we went all the way around one entire circle and landed back here at A, what would the displacement be? Well, the displacement at that point would actually be 0 because I've started and ended at the same spot. So if I went and calculated the average speed, I would take the circumference and divide it by the time. Sorry, I would travel the actual distance would be 1 circumference, 2 pi r, divided by time. That would give me my speed. But if I wanted to calculate the average velocity, then my total displacement is actually 0. And that means I would have 0 over the time, and my velocity would also be 0. I hope this helps. Make sure you get in touch if you need more help.